Oh, brilliant. Wow. Sorry? Ah. Okay, cool. Yeah, my name is Andrew. You can call me Andy. I'm here to talk about reliability engineering for agentic systems that never fail loudly. So, maybe by way of raising your hand, who in here has built an agent before? Who in here has built web apps, mobile apps before? Great. So we've got a good audience. Who in here has built any cloud infra DevOps related stuff? Anyone? Ah, great. Got some people. So yeah, this talk will be a bit balanced. So I asked the same question twice to my agents, and I got two different results. And basically, I built an agent to triage incoming issues from our GitHub, Sentry, and customer success team so that it classifies the category, or it kind of categorizes the issue and says, oh, this is an authentication issue, this is an infra-related issue, this is UI issue. And then goes on further to assign it to the relevant person who's supposed to work on it. So it was basically a multi-agent system that has a coordinator delegating tasks to a triage agent, then another agent that assesses whether or not this issue could affect our next release, and then the last agent that build a response. So I'm sure most of you have used GitHub before and you've seen issues. So as I was testing it out, one issue gave me a problem. I tested it with one model, gave me it assigned the issue to someone else, and then tested with a different model, assigned to a different person. So the issue was, this is like the basic summary. 104 issue number, the rate limit error is not surfaced to the user. When the upstream endpoint returns 429, the request fails silently and the spinner never stops. Nothing appears in Sentry. So this is what was reported. I want to ask the audience now, how would you classify such an issue? Would you call it an infra issue? Would you call it a UI issue? Would you call it an API issue? So basically it's saying a request is going to the server and the server is saying, hey, you've reached your limit for the number of requests that are coming in. So please do something about it. And then your web app or your Android app just doesn't do anything. It just keeps the thing loading. How would you classify this? Any takers? Infra. Okay. Anyone else? Anyone thinking different? Yeah. API. API. Okay, we've got infra and API. No one is saying it's a UI issue. Okay, I thought it was a UI issue. I thought it was poor state management. But turns out, after seeing this problem, I thought about it a little bit and realized this issue is not very straightforward. It's a bit ambiguous. So it could be a UI issue, it could be an infra issue, it could be an API issue. But one model says it's an infra issue. The other one says it's an API issue. The other one says it's a UI issue. How do I resolve this? The worst thing about this was that in all this, there was no error. So basically, I would run, okay, this is now the demo version that I set up. You'd run it and then I'll run it for you just now. And so I ran it with Gemini Flash and Gemini Flashlight, and it said it's an API issue. And then I ran it with Gemini 3.1 Pro, and then said it was a UI issue. So those of you who said UI, it was only me, you're aligned with the Pro models. So I don't know what that means, but that was a very interesting result for me. So I'll just try and run it now. Oopsie, you guys are seeing my calendar now. Okay, here is I'll run the demo live. So the model, I'm gonna run Gemini 2.5 Flashlight versus Gemini 2.5 Flash. And this is, so we're basically sending an issue to two models and just seeing how they both react. Hopefully it's gonna run a bit fast. Okay, so I don't know if you guys can see this. Do I need to increase my font size? I might need to do that. Is it legible? No, not at all. Is it, am I able to change the font size? Yeah. Does anyone know if I can change font size in Terminal? Can I? Command and plus. Ah, is this easy? Okay. How about now? So you'll see that, again, I was lucky with my demo. The, the models disagreed. So the first model says it's an API. The second model says it's a UI issue, and they assigned to two different people. So, but they can't both be right, you know? So one of them has to be right and the other one has to be wrong. But how do I know it's right or wrong? Okay, got a question there. Is that a win? That's the question we're trying to answer with this talk. Very interesting question, because that's the same question I had. Like, how do I know which one is valid? And one of the lessons I learned to answer your question is it depends on your setup. So in your systems, you would know what this means. You know, for an AI, you know, remember AI models are stateless. They don't know all the context in your organization. But when someone in your organization reports such an issue, they probably know what that means. And you, as like a person who's responsible for the triaging, would know what that means as well. So that you would take the one that's more consistent with what your organization interprets this issue to be. But yeah, as we just saw in the demo, the two agents disagreed consistently. They've disagreed with each other ever since I started playing around with this, and they always disagree. Turns out a newer, more expensive model is bringing another insight that the older model doesn't. Whether or not that insight is right, we don't know, because the real issue is that a case that is ambiguous has been brought to the LLM, and the LLM doesn't have full context. So, but in a normal workflow, let's say you've deployed this to your users, this would not say error. You know, your user will either get Amara allocated as an API issue, or Dlamini allocated this issue as a UI issue. But whether or not that's the correct thing, your users won't know, you know? So it might be a problem. And if it's like, if it's a high stakes type of application, then this decision would be very catastrophic. But yeah, so it will return error, status code 200, everything good, everything, your browser will load, it won't get stuck, your loading thingies, and everything in your application will essentially continue running as if nothing wrong happened. He asked the question, which one do I ask? Which one do I trust? I also have the same question. Both were confident, both looked reasonable. So this is the first test that I ran. And you'll see that 100% of the time, the newer model was like adamant, this is a UI issue. And then the cheaper model that I started with was like, this might be, because it said it's an API issue 80% of the time. Then the other 20%, it would be like, it might be an infrastructure issue, or it might be something else. Then I ran another check. I tweaked the prompts slightly keyword. So in the first prompt, I had, it said, you must use the tool lookup. So it kind of forced that tool lookup to be used. And in the second prompt, when I was updating it, I just said, hey, try to be concise, right? Don't overthink things. All right, I think I said, just try to be concise. And that one edit of just asking the AI model to be concise broke three things. Number one, the AI now started, it's just stopped checking the tools. So by tools, I mean, when you're running an agent, sometimes you want it to look in your database, right? Sometimes you want it to look to maybe a web page, or its tools are basically what the agent uses to interact with the real world, with the external world. So it can be Google search as a tool, or a database connection as a tool, or a file as a tool, or file system as a tool. So you basically tell your model, oh, I give you this tool, web search, find out information about this. Or you say, in my case, I give you this issue, find in the database of users who is the right user to allocate this issue to. So it started breaking after telling it to be concise. It started calling the tools only 88% of the time, meaning that some of the time it would just make up a name and allocate to someone who doesn't exist. And it also got the names of the people wrong, and it broke down its own structure, or like the response structure that I was expecting, meaning that it became a little bit unusable. Because when you're asking the AI to return something, you want a consistent response structure that your app can consume. So that got broken as well. So these are the examples of the people that got assigned. So you got infra owner, API team, no owner found. This one was an interesting one, because this probably means it made up a category or a team that doesn't exist, and then couldn't find an owner for that team. And then triage probe was the most interesting, because this is the name of the agent. So it said the owner is me. Weird. So none of these is a person in my database. Like I said, triage probe is the agent itself. So two changes that seem normal, two changes that in a pull request would never get stopped, two changes that are very reasonable. I'm just upgrading a model because we want better results. It makes sense, right? I am tidying up the prompt, because this thing is being too verbose. So I want it to be very concise. it's a very reasonable prompt engineering technique. We all do that, I think. All of us have used ChatGPT, right? Or Gemini. Yeah. All of us have used Gemini, right? Wink. Yeah. You say yes. He won't give you a present if you say no. So when you use these AI models, sometimes you have to tweak your prompts to get the kind of result structure that you want. So for instance, you wanted to write your essay or you wanted to build a report for your boss. Sometimes it adds certain sentences that you don't want. And you're like, hey, be concise, remove this AI language. You sound like a robot. All those things that we normally do. Doing that in code sometimes can be catastrophic. It means your app will fail silently. Your app begins to lose the predictability. Yeah, that's the word. Predictability. Where you were expecting a certain issue to be assigned to one team, team X, now the issue is assigned to team Y. Yeah, in short, reasonable changes drops the app's reliability. Keyword, reliability. So, but reliability is not a new problem. We've had this discipline for many years now. And it exists because systems usually fail in a way that our monitoring systems cannot fully capture all the time. So sometimes we have Sentry, sometimes we have cloud logs, sometimes we have Firebase Crashlytics, etc. But it's not all the time that these tools capture the reliability of our applications or the failures of our applications. So the basic 4 ideas that reliability taught us are that number one, you need to have some metrics that you agree on in your organization that say, this is the statistics, the set of statistics that is most important to us. So for web engineers, this would be time it takes to load a page, right? For yeah, I think time to load a page is like one of the most common ones. And then for database engineers, it could be maybe speed of the queries, I guess, query latency or number of active transactions at a time in your database, or yeah, list goes on and on and on. And with these metrics, the second thing that you need to agree on in your team, in your organization, is how much failure can you tolerate? For example, I think if you've listened to the Google I/O or these big companies' product launches, they keep talking about, we want 99.99999% availability. So that is a metric that they track. It's speaking to the reliability of their service, of their application. Number 3, once you've established those, now you need to break your system on purpose to see how you do against those set metrics, those agreed metrics. And then number 4, you need to be able to replay any failure, or at least most failures. It's probably not very possible to replay all of them, but at least 99% of the time you should be able to replay. So by replay, I mean, I don't know if anyone has used tools like Sentry, like where, so what Sentry does is it receives an exception. I think Firebase Crashlytics probably does the same, but it receives an exception in your system and then gives you all the context around what was happening. So like the session information that was there, except for the personally identifiable information. The classes that were running that had been invoked, the buttons that had been clicked, things like that. The device that the user was using, so that if you really want to replay this incident, then it's easy for you. So in reliability, you need to basically have that set up for most of your workflows in your applications. So the good thing is that the four concepts that we just discussed transfer nicely into agentic engineering. But the metrics are different because the time it takes to load a page is not important. You're just making an API call to an external service most of the time. So the time is really not something that you can control. The time is controlled by Google, Claude, ChatGPT, etc. So the metrics are now different. How do you measure reliability in an agentic application? Okay, before we go there, how would you normally measure? So this is an example. You'd say, I want all the requests that go to my server to be responded to within 200 milliseconds. But that is not very useful. I think that's the stuff that I just said. Yeah. We've got new kinds of metrics that are meant for AI agentic applications now. And these are like some of them most widely talked about, but there's probably more metrics that you can think about in your respective applications that you're building. So number one is how many answers from the queries that we're sending to the models, how many answers, correct answers, are we getting? So it's like, if we send 100 queries, how many times do we get a wrong answer? And then valid action rate, how many times do we get the valid action? So if it's like a sequence of actions or if it's the right choices of tools, how many times do we get that, right? And then tool call rate. So for example, in my application, I expect my model to look for people to assign 100% of the time. So it should always use the tool calls. The moment I have a 90% true call, then I know I've got a bug. I need to fix it. And cost per rule answer, the correct answer, when you call your API, how many tokens does it cost? Because you don't want very expensive models. And then you can also talk about other metrics. So, okay, this one I'll run in, I'll run, oh. Anyone? Smile, please. Okay. So I'm gonna run this demo just to show you how you would structure your or how you would test your systems. This one it's one that will take a little bit longer than the first one we wrote. So basically, I'm testing out the two cases, or maybe more cases, as you'll see, of performance, of correctness, of tool call actions via a script that I just designed. So the script just takes, it keeps invoking the model 160 times to see how much of our metrics we are meeting and how much of our metrics we need to improve. So I'm gonna run it, but I don't know if this thing will run in, because this first one ran in 21 seconds. But the good thing is that I ran it earlier, so I might as well just show you the one I ran earlier. I ran my script 5 times, and it made, 32 calls to the LLMs, to the models. So you'll see, can you guys see what's on the screen? No, yes, no? Ah, good. You see that when I was invoking my agent using the 2.5 flashlight, I had 97.4 correct answers. So that's, and then now if you're building an application, you then now need to think, okay, is this a good, acceptable failure rate? Because now you've got 2.5% failure rate. Is this acceptable to you? If it's a medical machinery type of application, then this is not acceptable. It has to be 100%. But if it's just a, simple vibe coding tool, then it could be acceptable. And you've got valid actions. This one was 100%. Both of them were 100% correct. Then tool calls. Again, both of them were 100%. Median latency. This one is a bit slow. This one is relative. Oh, this one is actually very slow. Oh, yeah, because it's a pro model. Okay, yeah. Pro model is allowed to be slow. Yeah, and then you look at the token counts. So ideally, you want a cheaper token because expensive models are the ones that use up a lot of tokens and they don't scale well. So if you run your, oh, you guys are looking at the pizza now. I see you. If your token is invoking, if it's using about double the number of tokens that your cheaper model is using, then sometimes it's worth just using a cheaper model and optimizing your prompt and then rerunning this kind of script. So you'll see that for the first test that I described, where you just run the same prompt, give it to two models, the pro model 100% said it's UI, and then the other one, it was, okay. This thing, I vibe coded this thing. So guys, bear with me. Yeah. So yeah, but the pro model basically was correct 100% of the time. And then the other one, I suspect it was also correct 100% of the time, but the answers were different. Then more importantly, the one issue that I saw and I was like, this is really bad, was you tweak the model prompt and just say, hey, be concise. And then that made it start assigning things to Android team, which doesn't exist. Nicholas doesn't exist in my DB. And if I run it this time, oh, it's still running. Is it run now? Oh, okay. This one didn't work. At least we had a previous one. But yeah, so again, I measured the correctness. You'll see that the one with concise this time was 100% correct. And then the other one without concise was 97.5% correct, meaning there was a 2.5% failure rate. The right person, was it assigning the right person? The baseline with the full prompt without the concise stuff was higher, and then the one with the concise was lower. And then the valid action call, it was also higher for the baseline, but lower for the concise. So you'll see that for the most part, the concise one is not much of a gain, but I wouldn't have known if I had not run this test. So I would not know how much reliability my application has lost because of this wording changes, wording change, sorry. So that is the thesis. So yeah, I'm here to ask you to make reliability greater. This is so cringe. Then yeah, so how do we do this? Reliability, we can have reliability embedded in our systems. So more like similar to how we have tests, unit tests running in our CI pipelines. You can have model tests run whenever you change your prompts or whenever you change the model, just to see the performance and gauge if it's still acceptable for your app. And the gaps that I had in this presentation and in this setup was that currently it's running on my machine because it's a test, and I couldn't show you also the other thing, because I'm building it for work. So, and then the replay, I didn't configure the replay for the replay aspect of reliability that we talked about. But here's a few lessons that I learned. Number one was that result randomness was not a problem. So when I started this project, I thought that I was going to get a lot of varying responses each time I ran, but it seemed as though a model would just pick an answer and stick with it. Every time you invoke it. So it's like the variance between the answers was very low. So that was a very big surprise to me, because I thought models will hallucinate, but I guess it's because I lowered the temperature when I was configuring my models, my model calls. Then model disagreement is a signal about your question. So for me, initially, I had my own understanding of what an issue meant. And it was, for me, issue 104, the one we talked about earlier, was a UI issue. But then when the models disagreed, I realized it was actually very ambiguous. And this is a very practical thing in life, because natural language is not as accurate as mathematical language. Mathematical language, if if you say 1 + 1 is 2, it's never 3, and if you say it in German, it's still 2, right, Sylvie? Yeah. So it never changes. It's always the same. So, but natural language has got nuances. The moment you change one word, it may start meaning something. And that was a very big lesson for me. Ambiguity is the normal case, yeah. So when you're dealing with LLMs, you should prepare for ambiguity of like input. So if you give your users an application, they'll say something that's very weird, that's meaningless, and the LLM has to try to understand their intent given the context that you've given it. So ideally, the more context you give it, the better, but also the more context, sometimes if you're dealing with a very light model, it might affect the performance. And finally, this was the craziest thing. Oh, got a question. No, oh, you're just stretching. I was looking for questions, man.
How did you, how, what are the metrics for testing your model, right? I saw them with, you had like the Flash model, but those metrics that you use, where did you get them? Like, because for example, in ML, you've got predefined metrics you use, like F1 score, all that, et cetera, et cetera. So like that one, it seems like it's tailored specifically for LLM and not like measuring numbers. So you've got your solution and what you want out of the model. Now, the metrics can be nuanced based off what you want out of the model. So like, I just have a question. How did you get those metrics? And then secondly, with the API, not sure, not you being sure about what is the problem when it comes to maybe UI state or API, whatever. Isn't logging, like, for example, if you said the server, it tells you that you have been rate limited. It can't be the UI. Or am I wrong?
Okay, that's cool. I'm gonna just go to that issue. Yeah. So the reason why it would be a UI is that the spinner never stops. So if the spinner never stops, if that is interpreted to be the problem, then it's a UI problem. You get it? Now I can hear you, but let me come closer. It, he doesn't want you to speak, man.
Because it keeps making requests the whole time, the UI state keeps making requests. That's why it would be a UI problem. I'm asking.
That, and also that you're not updating your state. So in the UI, if the spinner, if it keeps saying loading,
Yeah.
then it's a UI bug, because ideally, if a failure happens from the server, then you should update your UI and say, hey, user, I failed to do this. There was a server error or something else,
Yes,
you know.
yes.
But if you're not updating the UI after your app crashed or something, then that's a bug.
Yeah. Okay. Cool.
You get it.
But my real I was just confused about that. My
So,
real question
yeah.
was on the model metrics.
Yeah, the model metrics, it's not yet established because this is a very new thing and there's a lot of debate around it going on. But these are like the most common. So I looked up like websites that talk about it, because after hitting this, I had questions like, how do I know my app is reliable?
Yeah.
So I then started looking up, and there's a website called, I think, SRE or something like that, for agents. And then that's the one I used. And then I looked up a couple of other websites, and then that's where I got those metrics. So it's basically, there's a lot more, by the way. There's a lot more metrics that other people are using, but these are like the most common, the ones that I use now. But depending on how you use the LLMs and which like ADKs you're using, you may choose different metrics.
Yeah.
And for some, and it also depends on use case. So if you're building like something fun, something that doesn't threaten life, then maybe your metrics won't be caring much about accuracy, right? It's like it can be inaccurate. Let's say you're building a thing, what do you call it?
Image generator or something.
An agent for giving people jokes, for example, like telling people jokes. Send my wife a joke every morning, or tell my wife I love you every morning. And you build your agent that does that. Sometimes if it fails, it's okay, right? So you really don't care about how accurate it is. It's just like, I mean, if it's accurate 20% of the time, then it's cool. If it's not accurate, then it will just fail. And then that day she won't receive an I love you message, but but it's still fine, right? He doesn't agree with that. Now, question, yeah.
Or I disagree with the part where you say, if your agent fails to send an I love you note to your wife, because that might be an issue later. but for other things, yeah, it's okay.
I knew it. I knew it. Okay, I've got another question there.
Okay. So my question is, in terms of the metrics and this data, it's just taking from Gemini. Yeah, did I get that right? From the Flash and the Pro version of Gemini, right? So I'd like to ask, did you try prompting like a different LLM on that specific issue, or did you just do Gemini and the Flash and the Pro version?
Okay, yeah. Good question. I did not. I didn't try other models because why? Gemini is awesome, isn't it?
Yeah, but I mean,
You want to get the present, my friends. Gemini.
okay.
Okay, yeah. But I didn't try other models
Okay.
because I was using a tool called ADK by Google. So it comes out of the box optimized for Gemini. If you want to do other models, if you want to integrate with other models, then you have to do a little bit of work. It's not too much work, but when I did it the first time, not on this project, the other models would respond very slowly until I was like, this is not working for these other models. So, but yeah, that's
Gemini
the
is
reason why I
always your
just,
go-to.
yeah.
Okay. Thank you.
I do have other apps that use other models though. But for this one, because I used ADK, that was the reason. You can ever have. Because if it doesn't say this, then it will always hallucinate. Okay, not always, sometimes. Sometimes it will hallucinate because an agent that doesn't know to say, I don't know, is an agent that is capable of hallucinating because it doesn't know everything. Yeah. 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 Okay. I wish these questions were so good. I wish these guys had a mic, but I will, no, it's input rather. But so I'll try to address them one by one. Number one, with agents, and I want to be careful here and say agents versus LLM because we use these things interchangeably, but they are different. So with agents, you do your prompt, you design your prompt, and then you say, hey, you take input from a user and run with this, right? And you invoke an LLM. Now, when you invoke an LLM, oh, he's saying my time is up. Do you guys want pizza? Okay, so just listen to me for 1 minute, okay? 1 minute. So when you invoke an LLM, you can adjust what they call temperature. Temperature, if it's very, very low, it means it will only use the data that is supplied. So it will not be too creative. However, by default, we normally don't want to lower the temperature because it's not very creative and we love creative LLMs. So we just leave the temperature a little bit high, not too high, but not too low. But if you really if you want something that is always factual, then you have to lower the temperature and sometimes you have to tweak other parameters like top K, top P or something. It's basically telling it how to choose the next word. Does it choose the next word because it's just the most likely one or because of other factors? So, but yeah, you can adjust that. Then the second part was to do with, can you say? Oh yeah, so with agents are not exposed to the internet. You give them internet as a tool. So if it's supposed to call or to search something on the internet, then you give it access to the internet. This particular one didn't have access to the internet. So it was strictly something that I used for my, yeah. So I would make an API call to Google, but Google would not go to search for anything else. So yeah, that is basically how I set it up. But I think without much ado, I will leave the floor to the organizers. Thank you.
Thank
Such a
you.
great
Thank
audience.
you. Can we have another round of applause?